Welcome, class! Today, we're tackling the essential theory to make your engineering simulations a success.
So are your simulations failing? It's often due to a weak theoretical foundation. Let's fix that.
Okay, here's our game plan. Follow these steps and your analysis will be accurate and reliable.
First up, and this is super crucial, is simplifying your geometry. We call this defeaturing.
Why do this? You get smaller, faster meshes. It saves time without sacrificing any accuracy.
Think of it like cleaning your desk. You just get rid of anything that doesn't help the analysis.
But a word of caution here. Removing the wrong features can totally wreck your results.
Removing internal fillets, for instance, can create sharp corners, and that's a big problem. Let's see why.
This is a super common error that creates bogus stress results, making your simulation basically useless.
Okay, step 2. We need to tell the model how it's going to interact with the world.
Without these, your model would just float in space. We call that rigid body motion.
So our main goal here is to stop that movement, to lock it down in static equilibrium.
Now, here's a fun fact. For solid parts, both of these supports do the exact same thing. And a quick but important note on loads. Never apply force to a single tiny point.
This principle is exactly why we must apply loads over realistic areas, not on single points.
Doing this spreads the force correctly so you don't get those false, infinite stress results.
All right, on to our final theoretical step. Your problem has to meet 3 key conditions.
Now listen, if your problem breaks any of these rules, your linear static results are no good.
So let's bring it all together. How does this theory look inside the actual software you use?
You see, that study tree in your software isn't random. It's a direct roadmap from elasticity theory. Apply these principles, and I promise you'll see a huge jump in the quality of your analyses.